Hello, everyone. Welcome to the continuation of today's session of inverter-based resources studies, or actually presentations. As you can see, we have 3 more presentations to go till the end of the day. Our next presentation is on the grid import tool for EMTP using CIM CGMES format by Cesar Martin from RTE. Before we start with his presentation, I wanted to tell you that the slides and the recording of this presentation will be available at one point. We will start uploading those in a few days, so you should be fine as far as this goes. You don't have to worry about whether the slides will be available. During his talk or during any talk that we will have today, I encourage you to ask questions. So in your go-to webinar window, there is a questions menu. So as soon as you have a question, feel free to type it in, and then at the end of the presentation, we will read it and answer it. And then a final note is that the link that you have used today will work for all the other presentations till the end of the day. So if at any point you disconnect and you want to come back, the same link will work for the other 2 remaining presentations as well. So without further ado, let me introduce our next speaker. Cesar Martin holds Master of Engineering degree from École Supérieure d'Électricité in France. He works at RTE as a research and development engineer, and his focus is software development and also participation in co-development partnerships that RTE has with EDF and Hydro-Québec. His interests include also development of new models for electromagnetic transient simulation, development of gateways between software, and also new calculation methods to speed up the simulation process. So Cesar, thank you very much for participating this year at the EMTP user conference. I will now make you the presenter, and then you can start with your talk.
Okay, hello everyone. Can you see my presentation?
Yes,
good?
Yes.
Okay,
good.
Perfect. So, hello everyone. So I'm Cesar Martin from RTE, and I will show you a tool developed at RTE used to import network data into EMTP. So this tool may be integrated in a future release of EMTP. So today we have several simulations tools, and sometimes you want a network in EMTP that is already modeled in another tool. And we had this issue at RTE, and that's why we developed this gateway. So input data are in CIM CGMES format. So I will explain it later, but these are simple text files in XML format. So here is a plan. We will start with a quick demo to fully understand how our gateway works. Then I will give some details about the CIM format and the gateway features. And I will explain also why and how it's used at RTE. And finally, we will see the future works. So let's start with a quick demo of the gateway. This is the GUI, the graphical interface. And for the example, I take some NSOA test files. So the GUI is very basic. We select in the 2 first input the input, the XML files. So I will check, I will set, for example, this test file, and we can select also a destination folder for the ECF file. You can select the EMTP version, the frequency also, because in the CIM format, data are in home, so we have to select the frequency. And you have a configuration tab here, when you can choose between auto layout or diagram layout file. Because sometimes in CIM, you don't have the coordinates of the components. So if you want to draw the circuit, you have to choose the auto layout. And you have also other configuration options. So I will show you the auto layout features with a small grid. So I click to import. So the first step is to load XML files. So it loads XML files. It will open a new instance of EMTP, and then it will draw the circuit by positioning components. As you can see here, if I zoom out a little bit, okay. So you can see it's drawing, it's putting components on the circuit, okay, and it's drawing the EMTP circuit. It's faster when we reduce this the EMTP window. As you can see, the progress bar is faster, and the final step is to connect components between them. So we'll see. So now we connect, so it draws the lines, the yellow lines and the red lines. We have different lines color for different voltage level. Okay, I will reduce the circuit to accelerate it. And in the end of the import process, here, an error report is generated in the text file. And so the final result for this is like that. Okay, so let's go back to the presentation. Here. Okay, so here is another NSOA example file, and for this this test we use coordinates that were inside the input data. That's why at the top we have the original circuit, and the bottom we have the circuit imported in EMTP, and we can see that they are graphically very similar when we use CIM coordinates. But CIM coordinates are optional data, so sometimes you don't have it and you have to make an auto layout. So I will now explain what is CIM and CGMES. So CIM means Common Information Model. It's a standard format that attempts to be accessible and understandable to all. And using a standard for data portability facilitates exchange of power system networks between and within companies. But CIM is wide. We can have, for example, market data in CIM. We can have trades, balancing, resource management, etc. But for us, what is important is CGMES. CGMES means Common Grid Model Exchange Standard. It's an NSOA standard, and it's a CIM, but for grid equipments data exchange. So that's why we focus on this. It's for exchanging data, and this standard defines a set of profiles you can see on the left. So topology for component connection. We have also geographical location. We have coordinates. We have dynamics profile, and usually we have one XML file here per profile. So now we look more in detail CGMES components and their connection. Main equipments are called conducting equipments. So here we have a line and a power transformer here. So they are conducting equipments, and they are connected for terminals. So in this example, each conducting equipment has 2 terminals. And in the middle, there is a topological node. And this is a classic way how CIM objects are interconnected. And below here, we have the content of an XML file. So the content of the input file. For a line, for example, as a line segment here, we have the resistance. Here we have X also. And this is flat XML. It's good because it's no tree structure XML. I find it very convenient to exchange data. Let's see now how the gateway works. So this is the workflow of our program. But we will focus on the box in the middle. So we start with XML files. This is the entry point of our tool. And we use a CIM XML parser to load into memory and translate it into an equivalent CGMES model. Yeah. This is the second block. And then we cross the red line in the middle, because on the left, we have the CIM world, and on the right, we have the EMTP world. So when we cross the line, we map the CIM model with an EMTP model. For example, we transform CIM components like as a line segment to EMTP components like CP line or P line. And finally, we use COM interface to draw the model and to get the final EMTP circuit. And in the end, as I show, we have an error report, and it can contain unmanaged components, essential properties for EMTP, but that are not available in the source files. So some of warning and error we can encounter. And we are also experimenting an export tool. So this is the opposite direction in this workflow. So the black arrow below here. So we would like also to, from an EMTP circuit, create the equivalent CIM XML file. So it's not completely done, but it's in progress. Here we have the mapping between CIM and EMTP objects. So in this table, you can see on the left CIM components, yeah, and their EMTP equivalents on the right. And there is no direct mapping between CIM and EMTP. For example, the equivalent of an SL line segment can be a CP line, a P line, or even RL coupled. It will depend on the properties of the SL line segment, the length, the presence of capacitors or not, etc. Okay. Other components for power transformers, the same problem. We can have different EMTP components for one power transformer CIM. Sometimes the mapping between CIM and the EMTP is very complex. So we use flowcharts as documentation to explain how the gateway works. And one important thing is that's why I insist on the S here, is that one or more CIM components can lead to one or more EMTP components. So in this example, for a power transformer, we can have two more RLC components that we will connect to the neutral if the R or the C ground attributes are not 0. So yes, here, as I explained before, we have two options for the positioning. If coordinates are present in the CIM files, we use them and we build the circuit on the left. And if the original circuit is too dense, too compact, like here, it's too compact, we can lighten the circuit using a scaling factor. And if there are no coordinates, we use an auto layout algorithm, like the circuit on the right. Okay, so here is how the auto layout algorithm works. So in CGMES, we have mainly substations interconnected by lines. So we consider in the graph on the left that nodes here are substations and the edge are lines. So we indicate how substations are connected, and we let the algorithm find coordinates of the node center. And so in the end, we have coordinates of all substation centers. And after that, we build component inside the substation here with high voltage level at the top and low voltage levels at the bottom. And we let enough space between each voltage level to insert power transformer, as in the figure on the right. Okay, so for the development of this interface, what were the challenges we face? So first is the lack of data, because sometimes the standard does not allow to export some data, such as some details on machine saturation, for example. But in general, the standard is quite complete. So what happens more often is that optional data are not exported, such as some short circuit data, homopolar data, even if the standard allows it. So the exported data could also be wrong, but that's another problem. So also, if the exported model here is a bus branch version of CIM, bus branch means it does not contain all the devices. So for example, you have some closed disconnectors that are not exported. And in all cases, average data or default value are used if we have a lack of data. And a warning is sent to the user in the error report. And so also challenge is difference solving methods, because to validate the model or even just to make the load flow converge, we may encounter problems. Load flow engines may be different between the original and the destination software. So, for example, you can have automatic power transformer type changing during log flow. You can have also two PV regulators that are not accepted in one software at the same node. So we need to comply with internal constraints of the destination program. For EMTP, for example, we have the positive sequence shunt subacceptance of a CP line that cannot be 0. So we need to put a small value instead of 0. So how we use this gateway at RTE? So at RTE, we use Convergence. Convergence is an external software. It's used for steady-state simulation. It can describe the entire RTE network from 400 kV to 63 kV. And there is an export module compliant with CIM CGMES format. The Convergence export module does not provide graphical information, coordinates, because it's an optional information and they don't provide it. So we need to find a way to draw the circuit, and we can choose between auto layout on the right or use an external database of devices coordinates. This is a circuit on the left, and to get the real representation of France. Here are some figures for the total 400 and 225 kV grid. So for about 2,000 lines and loads, more than 1,000 substation. And in the table below, we can see that for this grid, so for the second line here, for this grid, drawing time is about 15 minutes. So this is the most time-consuming process to draw the circuit. And load flow calculation for a huge network like this is about 2 minutes. And in the end, we check that the import is successful by comparing load flow results at each node. So we compare voltage and the phase and power, etc., between Convergence and EMTP. And we have another automatic tool for that comparison. So at RTE, I can show you some examples of application cases that need a large-scale network. The first example shows time domain simulation application case. It used to analyze the background harmonic amplification phenomena during the energization of a cable. So in this case, the RTE 400 kV grid with specific topology had a decisive influence on harmonic resonance, So we imported the whole network, and then in EMTP, to shorten time domain simulations, we use a frequency dependent network equivalent, FDNE, on the network. Yeah. For the second application case, this is for offshore wind farm connection to the network. We provide harmonic impedances of different network topologies and short circuit powers. And for this case, not only 400 kV, but also some parts of 225 and even 90 kV grids are imported. And no FDNE reduction is needed for this application case because frequency simulations are fast, even with the complete network. So what are the future objectives of this gateway? So we have still other CIM components to handle in the gateway. We don't handle DC components now. We also have dynamic components that are partially handled here because we successfully imported standard models of machine control. We have in EMTP a library of standard exciters and governors. And these equipments are included in the CIM standard. So we can map directly, we can map them together. But the dynamic profile is divided into two categories in the CIM. We have standard models and user-defined models. User-defined models support the exchange of proprietary models and also elementary control blocks. And this is complex, and it's not handled yet in the interface. Okay, so then we have also a lot of other things we can investigate. We can improve the current gateway. We can improve graphical rendering of the final network. I think I have an example of a big network with 4 or 5 voltage levels. Okay, like this. This is a big network we imported, and if we zoom the circuit, I will try to zoom because it's. If we zoom the circuit, you can see that line cross in all directions, so we can get lost in this huge circuit. So we can imagine using sub-circuit boxes for substation. So one box here, one box here, one box here, and connect the sub-circuit between them. Or even we can also imagine separate different voltage level in several pages, in several EMTP pages. It could be a configuration option in the program. It could be here in the configuration tab. We could add some options for the graphical rendering. Let me go back to the presentation here. So we can also make more effort on the export mode. I mentioned it previously. We can try an import-export loop and compare original and generated XML files. For the node breaker configuration, also I will explain what is it. It's a detailed network topology. It's part of CIM. All the tests have been done with bus branch model. Bus branch is a simplified version of a network topology. So we can test a node breaker. That is a detailed version. So we have never tested it, but in May works we need the test case for node breaker. Also, we can test other CIM version. We tested with the latest CIM 16 and CGMES 2.4, but we need to test our gateway with new and previous version of CIM. Extending the CIM standard to include EMTP, EMT data is also a key point for data portability between EMT tools. Because, for example, we have, if you take the switch object in CIM, this class could be augmented with 2 new attributes to represent events in time domain simulation. you can add opening and closing time. It's not present in the CIM right now. So sometimes the issue becomes more and more complex for high frequency transient. In the case of a line, of an line segment, CIM, we can add additional data like the representation of towers, insulators, and grounding impedance, etc. We also have a surge arrestor model implementing in any EMG tools, but there is no CIM equivalent to surge arrestor to date. So this gives an insight of the complexity of converting EMT data to CIM format. And another point is to push the standard, because we need to communicate on this standard to use the software publishers to use CGMES for exchanging data instead of using proprietary format. So if you have any questions, but I think I have a little time left to show you some things, to show you the complexity of some CIM objects sometimes. I will show you a slide. Yes, this one. Here are all, this is all CIM objects that describe a synchronous machine. So in the XML file, you can have an object synchronous machine here. And you have to look if there is also a synchronous machine dynamics. So if the dynamics is not present, you use a simple voltage source in EMTP. But if there is a dynamic component here, you can use a real synchronous machine with stator resistance, with stator leakage reactance, with damping, etc. So the mapping of synchronous machine, for example, it's very complex. And if we look at the flow chart here, if we look at how we map synchronous machine, we can see it's very complex. There is different cases. We have to look at different properties, different objects. So yes, this shows how CIM can be complex for some objects. Okay, so I think it's done. So do not hesitate if you have any questions on this presentation.
Thank you, Cesar. So now let's, as you said, proceed with the questions. In your GoToWebinar menu, there is the questions section, so there you can type your questions now. So Cesar, let's start with this one about the HVDC models. So is there a way to handle those with this version? How, or rather, how are those? Is there at least if there are any plans to include HVDC models in the future releases?
Yes, I saw some documents on the NSOA website about this. For now, it's not handled HVDC models, and I didn't see HVDC models in any CIM files I received. So I think because there is a website with lots of documentation on CIM, lots of future works that will be done, and they talked about this, but it's complex. It's very complex for this kind of object. And one thing to remember is that CGMES was done first for static components, static properties. They are adding progressively dynamic components, dynamic properties. And for now, HVDC, I think it's not model like other equipment, like I said, the surge arrestor, etc. So I didn't see any models about HVDC. Okay.
And what about the control models or control system models?
Yes, so control models, here they added a dynamic file in the new CIM standard, and we have the standard controller. Standard controller standard IEEE controller are present in the CIM, and it's already there are already lots of components to handle. So for this, we can map directly with the EMTP library. One thing that is more difficult, and I've never seen this in test files, but it's the standard allows it, is to exchange elementary block of control, again, etc. So it's allowed in the standard, but it's not well documented and well structured. So no. For elementary controller, I think it's future works, yes, because it's not handled now, and yeah, there is also a user-defined controller, but I think it's future works also, because I've never seen this in CIM files.
Okay, thank you. So just to sum up, all the controls, when we say controls of synchronous machines, exciters, governors, power system stabilizers, those are taken care of right now.
Yes.
But control systems in general, be it an inverter controller or any other control blocks that you may have, those are allowed in the standard, but this is something that is not widely used by
yes,
software companies.
It's not widely used, and there is no real documentation on this. For example, for every exciter here, you have the macro parameters. They are well defined in the standard, and it's perfect. But for other controller, there is nothing. It's just a user-defined model, and maybe the source software and the destination software they should be compliant with to use the same control, and yes, it's not documented, so yes, it's complicated for this. So that's why we first need to take care about the standard, and let's see how it evolves for other elementary control blocks.
Cesar, can you also tell us what are the software platforms or simulation platforms that participate in this standard? So what are the original destination, or not destination, sorry, the softwares from which we can expect to take a model and import it to EMTP using this gateway?
Yes, I think that PSSE has a CIM compliant export module. I think it's free. It's not free, and so that's why in EMTP we have a PSSE format import module. But because because PSSE you need to pay a plugin or something like that to export in CIM. That's why sometimes it's hard to find to import some data, because the software publisher does not provide or it does not provide for free a plugin or a functional features to export in CIM. I think that PSSE is able to do that, but I didn't test it. And lots of course for us convergence is a tool at RTE that we use for planning tools, and it's able to export in CIM. I think all planning tools are maybe yes. I think they can export in CIM CGMES, but EMT tools for now. Maybe Silent also. But I have no. I didn't test it. I don't know really.
Okay. Okay, because that would also be interesting, being able to share models between different EMT platforms, not only import from transient stability or planning software, but also be able to communicate models, share models between different EMT platforms.
Yes, exactly. And we started exchanging with other EMT software publisher to use the standard. And I think CIM CGMES it's a good starting point for exchanging data because it's well documented. Okay, it's for static data, but they are adding dynamic properties, and it should be the base for exchanging data. And then if there is some information that are missing, then we can push the standard to include EMT properties. But the first step, if we succeed in exchanging CIM CGMES, it's already a good step.
Yeah, and I would just yeah, please
yes.
go ahead.
Yeah, I said, and when I read the full documentation, I was very surprised of it's very complete. For synchronous machines, there is lots of information. So there is a few properties missing for EMT. Really, so it's a good base. It's a very good base to extend with the other EMT tools.
Yes, yeah, it seems so. I would just clarify for the sake of those people in the audience who are not aware of the PSSC import tool, that this is a separate channel that we have released, which allows you to take directly the raw file from PSSC, or also dynamic file and sequence file, and use those directly without having to use this CIM exporter that PSSC charges for. So you can avoid the CIM and then directly use your raw file and the sequence and dynamic file and get your model from PSSC to EMTP. I didn't know that PSSC actually charges for this CIM export module.
Yes, I think so, because when I started to test import, we wanted to test with PSSC, and it was not, we cannot do it. So maybe they changed now, but we have to check. Yeah.
Okay, and you also, therefore, you also expect that the same feature, whether it's free or you have to pay for it, exists with other similar software like Power World or PSLF.
Yeah. Yes. 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 We have to check if they are CGMES compliant. I think more softwares are now compliant with CIM. Maybe with some previous version, because there are lots of versions of CIM, but now it's more stable since maybe 2016, something like that. It doesn't evolve too much. So yes, we need to check and test imports. But for us at Archie, we gain lots of for drawing the world circuit, for testing a different topology, and it's very useful, I think. So yeah.
Yes, Cesar, thank you for your presentation. I think these are all the questions that we had for you. I see there is one question specifically about the PSSC import tool, asking what version of EMTP can read the PSSC raw file. And the answer is the latest version of EMTP. The exact version should be 4.1.2, and this version includes the PSSC import tool. However, you need to purchase a special license for this module. This is the PSSC import tool is treated as an additional module. Yeah, this feature is now available with the latest release of EMTP. Well, that's. I think with this we can wrap up this session. Not this session. This presentation. Thank you, Cesar. It was really interesting and informative and promising, I would say. In a sense, what features and properties can be taken care of by this standard, and it does look very promising when it comes to the ability to communicate models and share models between different platforms. So thank you for introducing us to your work on this.
You're welcome.